Hello, everyone, and welcome back. Now, I'm sure you thought that we were at the very end of Lee's Research and Development Session 2 video set, seeing how in the last video we said we were finished with it. But here we are back again with yet another Session 2 video.
Actually, we are done with session two. This is the addendum to session two.
Yeah, I mean, Session 2 is pretty much good to go. Well, it is, and it's up. But there is some more stuff that Lee wanted to add in, and he didn't really want to throw that into a Session 3 because it's just some nice little things that he just wanted a place to stick it. And so we're sticking it into Session 2. So, Lee, what exactly is it that you're wanting to add in?
Well, this little addendum here is kind of to do a little cleanup. People have probably started building their worlds and playing around, and they may have done things like try to see how far they can go in the world and realize that it might have broken, and that was a mistake that I fixed. So I need, or a mistake that I missed that we'll have to go back and address.
Okay.
And there's also some things that I want to put in as far a little bit more additional things to put in as far as prep work for when we start looking at multi-threading with this, which again we're not going to get into here, but I want to have the groundwork in place for that. And it also ties in with the fact that it would be kind of nice that instead of always starting at the center of the world, we had the ability to drop our character someplace else.
Yeah, not only that, but with the ability to drop our character anywhere in the world, you could demonstrate what happens when our precision starts falling apart.
Oh yeah, and it gets kind of freaky looking at some places.
Yeah, we definitely need to give a warning before demonstrating anything like that because it could cause some people to lose sleep at night due to nightmares. It's
Yeah.
just that scary. Okay, so in this video, what do you want to start out doing?
Well, let's go ahead and first fix the little oversight that I had missed before,
Okay,
which is inside of train patch.
it's just a bug. Bugs happen in development every day.
It's not a bug. It's a feature
Okie dokie.
just to test other people's debugging skills. What we need to do is subtract 1 from our size, which is up here, which we take the number of units that we want and we add 1 to it so we can get that nice extra vertex at the end of each row. We need to subtract that before multiplying the spacing to it to pass out for our patch size. And I had forgotten to do
And
that.
while we were there, if you want to scroll back
Yeah,
up
I'm
to the
going to
top,
go and fix this.
yeah, do you want to address that now?
Yeah, sure, why not? It doesn't really have to be a power of 2 because we're not going to be using LOD. It's not that big of a deal. Though powers of 2 will make life easier for you when texturing gets involved, especially if your textures are powers of 2. But you end up with some limits. Like the last power of 2 that you've got is, I believe, what is it? 32 followed by 64. So 32 works fine and works very well speed-wise. 64, you're kind of pushing it with some of the older machines. Some of the newer machines can run a uh, a, a size of 64 without a problem. So you would use 65. Beyond that, you're really looking at taxing your machine.
Hmm.
So the next power 2 past that's 128. So my big super Wempadine machine used to be able to run that before it melted down. But
But it melted down, so don't try that
yeah,
at home.
that's true. Yeah, you don't want to do that. And your new machine can probably handle it, but
Well, we'll
we'll
find
have
out soon.
we'll have to test it, right? But for now, we're gonna just not use a power of 2. We will use 49, which is 48 plus 1. So that works well for us. And we've adjusted the little not bug. Yeah, okay, the bug. So we fixed the bug. Now we can get back to work.
Okay.
All right. What we want to do is adjust the way the world is created. Right now, we're just using a nested for or a couple of nested for loops to iterate through adding in our patches.
And you're just starting based off of the tile side count to the negative of it through 0 to the positive both in X and Z.
Right.
So if we wanted to position our character several miles from 0, comma 0, comma 0, then we're just going to be positioned in a void of nothingness and be falling while world is being created, well, right there at the
At
origin.
the 0, right. Which is not ideal. So we can adjust that by looking at our current patch location. Right now, current patch location takes in the player's information, adjust it based on patch size, which is how we found that bug, by the way. We were playing around with it and we noticed our numbers were slightly off. So we found it and fixed it. So if you want to be able to adjust it so your player comes in and the world is adjusted around the position of your player, we take the current patch location and we add it to each side of the 4. So we can paste this in. We pick X. We have to cast this as an integer because for loops like integers, they don't work quite so well with floats, particularly when you've said you're going to be using an integer. So if you want to use floats, make sure you don't assign an integer. So go ahead and take this and we're going to add it to the end here. I'm also going to go ahead and wrap this so we can keep this all on screen at one time. We're going to do the same thing again for the Z, but this time we'll use the Y that comes out of current patch location. And we can add this here as well. Again, adjusting for Y. So if we build this, we should find that we can go in and move our character and the world will build around her location.
Well, I'm a fan of making sure that, for starters, it
Right.
just doesn't blow up at 0 and 0.
Right. Now, if you
That's
go
good.
just if you
What?
go just a little bit though, don't get crazy yet because
Okay.
we got to demonstrate the problem when you do
Yeah,
get crazy.
absolutely. So what do you want me to go? About 96 or so over, or I'll have
Yeah, well,
256, or
256 should work. That's
okay.
fine. A little bit of distance.
Okay, let's go ahead and see where. Well, we shall just frame up. There we are, and back away. Let's go ahead and play it. Okay. Though if people were watching carefully, they may have been able to guess what the problem was, but we are indeed still on land. We are away from 200, and let me frame up over here and back away in our scene view so that we could see, and then we could go a step further. So yeah, we're definitely dealing with different terrain altogether. And now what happens if we come in here and turn and start running and make sure everything continues to work fine with all of the other systems that make up the custom terrain system so far. So and we still have the 2-second scheduling for
Right.
the patches. But yeah, so looking good, and you can see we're starting to remove these patches behind us as we're running off that way. All right, very nice looking, Lee. So let's go ahead and switch back over and discuss what problem we do have.
Well, if you look inside of our current patch, you can see that we're casting to an integer.
Mm-hmm.
We're going in, we're taking our position, we're dividing it by a number, and we're basically truncating it to an integer. The problem that this is going to cause us is the further away from the center of the patch that we get, we're going to start getting some interesting non-rounded errors. So basically,
Truncation.
truncation errors, exactly. What'll happen is your current patch location is going to be reporting that you are on one patch when in fact you're actually closer to the other patch or downright on the other patch.
Right.
So when we were starting in the center of the world, this was a close enough approximation for determining when to draw new patches. But now that we're adding the ability to start anywhere, we have to be more specific with how we deal with this. So instead of using an integer, what we're going to do is use the mathf function called round to integer. this will take the output and round it to the nearest integer like you would expect it to. So if it's closer or if it's greater than 0.5, it's going to round up to the next one. If it's less than 0.5, round down to the next lower one. So this is the functionality that we'll want for our current patch location. So we'll paste this in.
Okay.
So now there's another problem that we get into, which is why we need to deal with, let me close some of these other methods down, why we need to deal with a new way of dealing with create initial train. We can demonstrate this, but go ahead and knocking the tile side count up a bit. Let's go with, say, 4.
I'm going to go with 4, zero ourselves back out.
We could,
Or
or
do you
we
want to just do it
could,
from right here?
well,
I mean, we can
we could
probably...
do it from right here. It's fine.
Yeah.
It should work now either way. But if you remember, we're using nested for loops, which means that it's creating a row of tiles, and then once it finishes that, it moves on to the next row, and the next row, and the next row. And it does it in a very sequential way. Oh, we need to do one other thing.
Oh, yeah, because you're going to get an instant... Well, actually, they can
no,
see
we'll
it.
actually get it. Yep, there it goes. So you can see how we're being created.
Unfortunately, well, I was going to say since we were high enough, but we weren't high enough. We went right through the problem. So that did a beautiful job of demonstrating the problem.
Yep, I was thinking it wasn't going to catch it.
Oh, it caught it all right. Fantastic. So obviously, we would probably like to see the very first patch being created beneath our character's feet, so, well, what just happened doesn't happen.
And I think the reason why is when we're doing the testing and undoing, oh, we've got it. No, that's there. All right.
It's there. The timing worked out flawlessly for us.
Yep. The problem that we're getting is the fact that we are creating our world in a very, very linear way. One row, then the next row, and then the following row. And it has to draw all those rows. And if all those rows aren't drawn before you drop the character in, the character is going to fall through the world. So what we need to do is reorder the order in which the patches are being drawn. We want to use a player location centric means of sorting. What that means is we want to start and draw the patch that is directly underneath where our player is starting at. And then we want to continue drawing patches in an outward spiral out to the extent of the visible world. So we'll draw the first one, and then we'll draw the ones immediately surrounding that, and such all the way until we get out to the outside world. To do that, we have to create a temporary list to hold all of our patches that we're going to create, and then we can come back and sort it.
Now, just quickly, I want to throw this out. We're not going to hold a list of actual patches, are we?
No, we're going, if you look how we create a patch, we say new train patch, and we pass in a vector 3. What we're going to do is we're going to save out the needed information that
to create a patch
is going to be used to create the patch. So we'll take that information, use that as a metric in which we'll use to sort our patches, and then pass that information in sequential order to the train patch method or constructor. So let's create that temporary patch list. So we'll call it patch list, and it will be equal a new list, and this will be a list of vector 2s. Like I said, we're not holding patches, we're just holding the information we need to create a patch. So we're going to create that list. We can use this same nested loop to populate this list. But instead of calling the patch, what we'll do is we'll add it to our patch list. So we'll go patch list.add. We're going to create a new vector 2, not a vector 3. We need to make sure it's a vector 2 because that's what we defined. We don't need to hold the 0. Every patch is going to come in at 0, so we just need the X and Z information for this part of it. Once we've built that list, we need to set up a way of sorting it. So to sort it, we need to hold a position, so we'll create another var POS. Inside of this, we're going to set it to a new vector2. And we're going to construct our vector2 by querying the current patch location. So we'll go current patch location .x and current patch location .y. So this is going to create a new position for us. It's just to keep it nice and tidy. We could actually use this inside of the next line, but this is just for readability. Now we need to create another temporary list. This is the list that we're going to iterate through that has been sorted. So we'll set var patches equals patch list dot order by, and hopefully it'll pick this up in a sec. There we go. We need to add the using system.link. So if we go up to the top, expand our usings, you can see it's given us system.link. Now, what we're going to do is say patch, goes to vector2 distance, and we're going to pass in our position and our patch. Now we can do this because the patch is nothing more than a vector2. So we're just comparing the distance between our position that we just created and our patch's location. And that will order our list in a ascending order. So the shortest distance are going to be at the top of this list, and the farthest distance will be at the bottom of the list, which is exactly what we want. Once we have that sorted list, we'll iterate through it, just doing 4 patches, or we'll say var patch in patches and new terrain patch. And inside of it, we need to construct a vector3 because terrain patch wants a vector3, not a vector2. So we say vector3 patch.x, 0, and patch.z or z or y.
Yeah.
My bad. It goes into z, but it's y. So if we build that,
All right,
and give that a shot, with 2-second time, we should be able to see it draw in an outward direction.
there you go. Beautiful.
All right, so we can also dial back in the numbers so it doesn't take so long to start. But if you want to start putting in a few random positions and see what happens.
Absolutely. Jump back over and have some fun with it now. I want to see what's all the way out at, well, let's just start simple. 2,000 by -3,000.
Now, do you want to adjust the number of patches that's going to draw, or you just want to go with...
I just want to go there.
Okay, well, go for it.
Play! If the system's all built right, it should just work. We're going to see ourselves land here in the game panel if all is well. But I'll frame up over here in a second in our scene view. Bink! Land it right on land. Now, back over here, let's frame up to see where we're at and start backing away. Are we on the ocean floor somewhere?
It looks like it.
It looks like we're on the ocean floor. We need a little mini map to see where we're at. All right, let's see.
Try 0 for X.
Okay. Oh, let's go ahead and just stop this. All right,
Yeah,
0.
we can't change it real time. And try about negative 4,300 or so.
Sounds like you know where that place is at, Lee.
It's home to a fairly famous motorcycle race. At least I think that's where it is. I could be off a little bit.
By just a few hundred miles, but hey, give or take.
But if that's the case, we'll end up in the ocean.
Again. All right, let's see. So, again, success with landing, well, on land. So that's good. Let's go ahead and zoom back out here. Looks like we're
right
on
the edge.
Oh, we are so on the edge.
Right on the edge.
Yeah.
Look at, I put you right on the beach at 16 meters.
I'm impressed. So let's just run on up here because now I'm not only impressed, I'm curious.
If anybody's wondering, based off of our map on the UK, this is the Isle of Man. Though not to scale, because we've got Jason altitude numbers dialed in. So this would be what the Isle of Man would look like if Mount Everest was on it.
Hey, the big mountains look cool. I'm sorry. They just do. Oh yeah, this is the not the new the MMO controller. Here I'm wanting to run in a direction and swing the old camera around and look. Whoopsie.
Yep.
I'm going to let a little bit back here build. Oh, it's going to be so nice when we finally get around to getting multi-threading in.
Yeah, it does make a big difference. I'm hoping that Unity fixes the bug in the editor, though.
Agreed. So that's not going to be such a pain with having to build out and back in.
Well, I'll probably end up getting to the point where I'm tired of doing it and just set it up so it's got pre-processor directives to figure out what it's building to, and then enable threads when it's on a standalone.
So is that ocean that I'm looking at back over in the distance and I'm like running around the side of it?
Yep.
Gotcha. All right, there she goes, starting to build some more stuff. Well, very cool, Lee. I mean, we were able to go somewhere that's definitely not in the ocean.
Well, let's try another little bit of numbers.
All right.
This one, I don't know where we're going to end up. Let's go with about 40,000 by 40,000 or negative 40,000. Whatever floats your boat, doesn't really matter.
Yeah, because this is where we're going to start to have a world that's just starting to rip at the seams a little.
Well, actually, I think this is about as far as you can get and still be stable. I think it's about 44,000 out. But you're definitely pushing the boundaries of where you can go.
Hang on. Yeah, she's got very... It's probably going to be too hard to pick up unless people are at home trying it. Every now and then, just a very small jitter. It's not that bad. Let's run a little. Well, let's also do this, because the other concern, whoops, is over here in the world, framing up, and we're going to see, not so much here, because it's holding up. Yeah, very good, Lee. It's holding up better than I was expecting.
No, on the test that I did, it was about 45,000 before things broke, so which is why I picked 40,000. You
still get some very subtle, and it could just be because of all the stuff that's running on the machine right now. So we might actually be okay. Let's go ahead and stop it, and we'll move it out to 46,000 then. Because then we should be entering into the danger zone then, right?
Yes.
All right, let's see what this gives us.
At about 40,000, that was the utmost of where I was still comfortable with going, yeah, that's close enough. The no shadow breakups and the character was running smooth on
And you were
mine.
saying this world size though is still what, at 2100
At 40,000, that's 2,100 square
square
miles.
miles? Yeah, when she shifts back to the left, let's see if you guys can see it. Well, it looked a little rough at first, but it's not too bad. Let's go ahead and find her. Yeah, it's still really subtle.
And at this point, you occasionally see a split in a seam,
Yeah, that's what I was.
but I don't know if you'll see it because it's all flat here.
We're way out in the ocean. We're just whatever little bit of noise, I guess. All right, let's
Now, if you double it and go out to about
yeah.
80,000,
Are you kidding? Oh, we can. They can fast forward. I'm curious. Let's just take little small 10,000 unit steps here.
all right.
I want to see if we can introduce it slowly. That's the beautiful thing about having a track bar. Fast forward. We can't fast forward, but I'm curious. Dude, she's still holding up fairly good. Let's see what the world's doing.
Oh, the errors you see are usually in the play screen, though. I don't know. I never checked in the editor.
Oh, that's a good point. You're absolutely right. Let's see. Yes, it's right over here somewhere. Yeah, there we go.
Yep, yep. We can start seeing it.
Yeah. As I run even further out. Get up to this hill. All right. So basically, if you watch, it's probably going to be difficult to see after we encode these, but every now and then the two patches split apart just a little bit, and you can see blue, then they come back together. Especially when you're doing a little bit of mouse movement. There we go. Now, let's jump up again. So, how about we go to... I'll go up to 70. So we'll take 20 this time. That's definitely going to make it a lot more noticeable.
And we don't have shadows in place either. That's something else that breaks.
Okay. And let me do two things. One, come out over here and frame us up. Jump us out and that's nice. Just walk forward a little bit. There's the seam. All right, so I'll take some bigger jumps. Even though we can see the tearing there, she's still holding up pretty well. So is the train. Better than I was expecting.
No, it's a gradual process
Yeah,
up until a couple 100,000
yeah,
out.
we're gonna jump up to a couple 100,000 out right now. We're gonna make it noticeable. Dink, dink. We'll just throw a whole 200 on top. There we go. But you know what, Lee? At least we have land under our feet every time we come in.
Yep.
Of course, this is going to make things a little unhappy here.
Well, the unique part of it, not the train part. The
Yeah,
train part's going, yeah, fine, not a problem. Here
this
you
is
go.
true. All right. Her left arm is now broken. Her shifting is, yeah. Let me go ahead and pull up out. You can do it. Maybe you can't do it. Come on, frame up.
Oh, you're trying to frame. I was trying to figure out what you were doing.
Can you not frame up, Lee?
No.
Not at all.
not that far out. You're
Yep.
outside of Unity's editor view space.
All right, now let's find out what's in the world. All right, come on. So as she's running,
Sort of.
I see, yeah, sort of. I see some seam issues right here. Now I'm not even touching the mouse nor the keyboard. All right, there we go. It finally settled down. Now if we touch the mouse and we start to move, you can see that we start to get a bit turbulent. Yeah, there you go. Our poor shoulder. But let's make it one final bit more interesting. So let's go ahead and throw another 0 in here. So that brings us all the way up to just a tad over 2 million. Play again. And this is what Lee was talking about when he said he let his character run for 30 some odd hours and the world and the character itself was basically tearing apart. Oh wow, in the mountains because of how things have wrapped around, but look at her arms. And every now and then all the crazy shifts. I am not touching the keyboard. Now I am, and the mouse. As okay, hang on. I'm gonna reposition myself. You guys just fast forward real quick. That was just a bad spot. So I'm gonna go to
Well, I took it out
-3.
to about a little over 7 million, so you can go out that far.
Yeah, but we're gonna get to a point where she's a popsicle stick that's just kind of doing the weird mumbo jumbo thingy. I mean, her arms and everything's folded all into just kind of like a stick.
Well, what's really weird is even on my machine, after the 30-hour run when I was at 7 million
There we
units
go.
out. Well, yeah, that's right. I didn't because I was using the fly-through camera system that I have. She wasn't in there.
Oh, the poor arms. All right, let's try to run. Blah, 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 blah. Oh, turbulent world. And you can
But
see
but the world still works. The patches are there. They have
patches.
gliders on them.
Patches are there, but we just don't have the precision to. Oh,
Nope.
man. Tell me if that's not some crazy stuff. Okay, I think this demonstrates our point nicely, which does bring us back to she can only go so far in the world. Anyone can only go so far in the world if we are not doing a treadmill style world. Now, again, for those that may have missed our discussion of treadmill style worlds in the past, Lee, go ahead and talk about that for just a second.
Well, a treadmill style world is basically you take your character and you stick them at the center of the world. Your character will not move. Well, I can't say will not. There are modifications to it. There are variants. But for the most part, your character either doesn't move from the center or only moves a limited distance before getting reset back to the center. So in that case, what you would happen or what you would do is you could set it so they moved out, say, 100 meters from the center of the world, and then when they got to that point, both the character, the world, and everything else in the world snaps over 100 units back. So she's in the center, and because it all happens within a frame, you shouldn't see any visual difference whatsoever.
Mm-hmm.
But the short of it is you keep the entire world within the functioning area of side of Unity, so you don't get the floating point errors. The trouble becomes storing real world information and then having to transform that information to a player local space. So everything has to be stored for the world, especially with an MMO. If it was just the player's experience, everything could be saved relative to her and it's or your character. It's no big deal. The problem becomes with an MMO where you have the potential for dozens, hundreds, even thousands of players that all have to experience the world. All the stuff in the world has to be kept in world space and then has to be translated or transformed into that character's local space before it can be presented on the client. we're trying to avoid it, because then you get into issues with figuring out AI, dead reckoning, and with all of the translations back and forth between all these spaces, we're um, we're worried that it could get very expensive and very difficult very quickly. So we're trying to experiment how big we can make the world without breaking Unity.
Of course, if we did want to, leave it zone based, 2,100 square miles is pretty darn big.
Well, yeah, for our UK people, um, our starting location is near, I believe it's Newton Stewart in Scotland. And we ran down to Isle of Man in real time at this scale. And it took about 20 minutes to run
And even then,
there.
weren't you running at 6 meters a second?
Yes, I was running at 6 meters
So
a
you
second.
were
So
you were really
yes,
getting it.
so if we were moving that down to average human walking speed, it would have taken closer to 40 minutes, maybe an hour to just get that far.
Yeah. So still, definitely big.
Yes,
Very
a
big.
very large world.
Well, is that pretty much everything you want to get in this video here, Lee?
For this one, yeah, they can pretty much drop in anywhere they want now. They can experiment, and they don't have to spend 30 hours to see what happens when you get, 7 million units away from the uh, the origin and see how bad it breaks.
Very true.
And then trying to think, as far as I know, that's most of the bugs addressed. Though I won't swear to that because
Exactly.
this is R&D,
That's right.
and every time I go to mess around with some new feature, I find something that I missed or I have to go back
It
and change.
happens. It happens.
So.
All right, fantastic. Well, with that, that is going to wrap up this video. Thanks a lot.